Hello everyone, RVD here and welcome to the next video of my playlist, a course on C programming, where C programming is simplified. In this video, we'll be looking at one more simple computation-based program to find the circumference and area of a circle. So for that, what we need is radius of a circle as input. So we'll have, let's say, float rad, which stands for radius. Then for storing the circumference, we'll create a variable CIR, and for area, we'll have area. The first thing we require to do is take the input. So we'll have a message, enter radius of a circle, which will be taken in a variable that is rad. Okay, it could be a simple r, or as we have created a variable rad, so it will be rad. Now the first thing we require to calculate is the circumference. Now the formula for circumference is 2 pi r, so it will be 2 into 3.14 into r, which is radius. Similarly for area, it is pi r square, so 3.14 into r, into r, that is rad, into rad. We can use power function, but it is just a square, so we can simply say rad into rad. So we got two results, that is circumference and area. Now we can print them. So printf circumference which will be CIR. Similarly, area. Now all of you know why I'm writing %.2f, so that I'll be getting up to 2 decimal places. And here we'll have area. Fine. So as far as the logic is concerned, we have taken the input of radius in rad, we have applied formula for circumference as well as for area, and we are printing both the results. Okay, so let us see. So let me save. Then we'll first compile. Okay, so we got the things compiled successfully. So let us execute. So enter radius of a circle. 7 is a typical radius for which we have a predicted output, 43.96, around 44, which we know, and then it will be 153.86, which is perfect. We can give any other input, and accordingly we'll be getting the result. So if the radius is given as 10, this is what we got. Okay, which obviously can be cross-checked also, because 10 square is 100 into 3.14 is this one. Fine. So as far as the execution is concerned, it is correct. I obviously want to give you one more concept here, that is the value of pi. See, this is called as hard-coded value. That means I had used 3.14 everywhere. Currently it was a small program, so I had to use it only 2 times. Imagine if at all I required the value of pi to be used, let's say 10 times. So the same hard-coded value of 3.14 is being used 10 times. Now obviously value of pi is very less likely to change. But suppose, let us take a hypothetical situation that, because it could be any other constant also, which is a temporary constant and whose value can change as a matter of fact because of the external factors. So currently let's not get into that. Suppose my value of pi is being changed, let's say from 3.14 to 3.15, or I want to just make it 3.142. Because you had used it 10 different times, and that to hard-coded value, we have to change that manually, and that to 10 different times. Now that can be avoided if at all I try to create this as a constant. Okay, so let us see how can we create this as a constant. Currently the only method we have is you create a variable, let's say float pi, assign a value to it, and instead of using a value, I'll be using that variable pi because it is going to obviously replace it with the same value. Now will it work properly? Obviously it will work properly. So let us compile and we'll try to execute. Let us try to execute, and maybe you are supposed to get the similar result. So what's wrong in this? Nothing wrong, but the problem is it is not a constant, it is a variable. So suppose by mistake, if at all somewhere someone tries to change it. Now here I'm doing it purposely, but you can understand if it's a big program, at some point of time at some line by mistake, it could happen that the value of pi is getting changed because of some expression. Now if this happens, how the program will react? Let us check. So I compile it again. Obviously compile time error is not possible because it is nothing to do with that. It is simply making a variable to 0. But see the answers. That is because your pi is not considered as a constant here. It is still considered as a variable. Now I don't want that. I want it to be considered as a constant so that even if someone tries to change its value by mistake, it should generate an error. So your C provides a keyword called const. Okay, now when we say const, let us see the effect. Okay, we have not done anything other than just making it const. Now immediately you can see there is a compile time error. Okay, now the error is too small, but I'm just reading it for you. Assignment of read-only variable pi. Now when you make it const, what happens is it has created a variable pi. It has kept that 3.14 inside, but because you said const, the value obviously got freezed. And because of that, at any line in your program, if you are trying to change the value of pi, it is creating or generating a compile time error. It is obviously saying that assignment of read only variable is not possible. You are doing that and that's an error. Okay, so obviously if at all I don't do that, it will not show me any error. Okay, so let us see if at all I don't initialize it, how it handles. Okay, so it is not giving me any error. Let us execute. Obviously, because if we have not initialized, it will be taking the default value, which is 0. And you know, because I made it const, I'll not be able to assign any value to pi thereafter. So what's the conclusion? Whenever you are creating a constant, you should obviously initialize them with the value, because that's the only place where the value could be kept in that particular constant, or that particular variable rather, which is going to become a constant. Fine, so that's a good practice. Even you can see I have kept pi, or I have written pi with full caps. Even though it's not a rule, but it's a kind of a convention that whenever we are creating symbolic constants, that is user-defined constants, ideally it should be created with full capital letters, all letters capital. So it is very much visible in your program. If at all there's something with all caps, it is considered to be a constant or a user-defined constant. Okay, so it was a simple program for finding circumference and area. We have done that as well. I hope you remember that. But along with that, we have learned one more thing, how to create constants in C. And we had seen the concept of const keyword in C. Okay, there is one more way which can be used to create constants in C, okay, which we will be looking at into our next video, where I'll tell you why this particular use, that is a const keyword use, is not preferable, because there are certain flaws or certain limitations, okay, which can be handled by the next method or next way we have to create constants. Okay, here we have actually not created a constant, we have created a variable, and using a const keyword we had made the value of that variable constant. In short, we freezed the value so that no one can change. What are the problems with that and how do we solve it with another method? We'll see that in the next video. As far as this video is concerned, it was about circumference and area of circle. We have seen that, and we have seen one additional topic, that is const keyword. So that's it for this video. Thanks a lot and a very happy learning to everyone.